Now let's look at a procedure for finding matrix inverses. So if you want to find the inverse of the matrix A, what you want to do is form this partition matrix. You put A on this side and you put an identity matrix over here that's the same size as A. Then you row reduce the whole thing, and this is what it row reduces into. If C here, if this side is the identity matrix, then this side over here is your inverse. If C doesn't turn into the identity matrix, then A doesn't have an inverse. So let's do an example, and I want to do this example by hand. Find the inverse of this matrix. Okay, first thing I'm going to do is I'm going to put the identity matrix next to it, and I'm just going to, rather than recopy it, I'm going to just slap it on the side here. So let's do that, and then we'll use the 2 here, or no, we'll swap rows 1 and 3. And that will give us a 1 in the upper right position. So we get 1, 0, 3, 0, 0, 1, 0, 1, 2, 0, 1, 0, then 2, 1, 3, 1, 0, 0. All right, now we'll use the 1 up here as a pivot to get rid of the 2 on the bottom. So we'll do row 3 minus twice row 1. All right. So row 1 and 2 stay the same. So 2 minus, let's see, we're going to get 2 minus 2 to get 0. 1 minus 0. 3 minus 2 times 3, so negative 3. 1 minus 0, 0 minus 0, and 0 minus 2. All right, so we get that. Now we're in luck because we've already got a 1 there, so we can use that as our pivot. We'll do row 3 minus row 2. We're a little fortunate we've already got a 0 here, so we don't have to clear that one out. So row 3 minus row 2. All right, so we get 0 minus 0, 1 minus 1, negative 3 minus 2, 1 minus 0, 0 minus 1, and negative 2 minus 1. All right, so we get this. All right, we've avoided fractions so far, but we can't do that any longer because the only way to get a 1 here is to do this row divided by negative 5. So 1, 0, 3, 0, 0, 1, 0, 1, 2, 0, 1, 0, then 0, 0, 1. And just to avoid having to write fractions, I'm going to do this as decimals. 1/5 is 0.2. 1/5 is still 0.2. And 2/5 is 0.4. All right, so we got that. You could write these as fractions if you prefer, but I feel like using decimals today. All right, just double checking things. Yeah, my sign's all flipped there. All right, so this next thing should be our last step. We're going to use this as a pivot. Let me do it in purple. We're going to use this as a pivot, and we're going to clear out the 2 and the 3 above. So we'll do row 2 minus twice row 3, and we'll do row 1 minus 3 times row 3. And I'm going to keep that, rather than go back over here, I'm just going to do it immediately below. So row 3 stays the same. All right, let's do row 2 first. Row 2 minus twice row 3. So that's going to be 0, 0, or no, 0, 1, 0. Then 0.4. Then let's see, 1 minus 0.4 is 0.6. And then negative 0.8. And then top row minus 3 times row 3. This gives us 1, 0, 0. So then we get 3 times 2 is 6, so 0.6. Then negative 0.6. Then let's see, 1 minus 3 times 0.4. So that's 1 minus 1.2. So negative 0.2. Now, if I did all that correctly and didn't make any silly mistakes, this is our inverse. Let's see, our original matrix didn't have a name, so I'm just going to label this inverse. And that's it. Now, I feel like I should check this on Octave, and I'm going to show you a couple of different ways to do this on Octave. All right, so let's call this matrix A. What was it? 2, 1, 3, 0, 1, 2, 1, 0, 3. All right, now once I've got that, here's an interesting thing you can do with Octave. I can put A and then I3. Maybe I need to put brackets. Yeah, if I put A and I3 there in brackets, notice it puts the identity matrix on the side. You can't quite see the whole thing. Let me slide it over. All right. If you do this and you put a semicolon in there, it stacks the matrices on top of each other. But we can take this and we can row reduce it. And let's compare that to what we got up here. 0.6. See, looking at this bit over here. 0.6, 0.4, negative 0.2. Yeah, that's looking good. Now, there is a quicker way to do it on Octave. You could just type in inverse of A, and that also gives it to you. Let's see, or A to the negative 1, it'll take that as well. So Octave can do these for you quickly. Let's see. There was a second part to this problem. Let's go back and look at it. Use it to solve the matrix equation AX equals that. I guess this matrix was supposed to be called A. Okay, so here's the deal. If you have AX equals 1, 0, 1, what you can do is you can go back and multiply on the front A inverse like this. And here's the nice thing. This cancels away and just leaves you with identity matrix times X, or just X, equals A inverse times 101. So we can do that pretty simply. I'm going to use Octave to do it because this video is running long. So there's my matrix A inverse. I'm going to multiply it by the column vector 1, 0, 1. And it gives me this. 0.4, negative 0.4, 0.2. All right. I think we'll stop this video here.